You can continue, Miroslava.
Yes, I've start my sharing of screen. Yes, demonstration. Do you see my last
Yes,
slide?
yes, we see.
Yes, thank you. In order to provide understanding of the full functionality of the system, its limitation, input, output data, phase and detailed structure, a detailed description of the quality control system of polyethylene production as highlighted the main technical characteristics. A detailed description of the database structure with the corresponding area diagram is given. This manual contains a number of detailed step-by-step steps for using the system, outlines the main functions that can perform this control example as was illustrated as main feature of this interface. To verify the compliance of the system with the described requirement as well as the analysis of the efficiently to do, a startups sequence analysis of the control example was performed. During this action, each of these main functionality of the system was implemented, namely quality control of polyethylene, inspection of each stage of production, analysis and reporting. After the analysis, the compliance of the system with the specified requirement was confirmed. Thank you for your attention.
Thank you very much, and sorry for interruption. Maybe somebody has a question. Dr. Budnik. No question. Then we thank you again.
Yes, may I start my next presentation? Or are you ready, Oksana Boyarchuk? Are you ready?
Maybe better if it will be Oksana Boyarchuk.
Okay, okay. I will wait.
Thank you. Now?
Okay, yes, we see.
We see? Okay.
Yes, yes.
Okay, thank you. My name is Oksana Boyarchuk. I'm from Lviv State Agrarian University, and I present a report forecasting the fund of time for performance of works in hybrid projects using machine training technologies. The aim of the work is to substantiate the approach to forecasting the time fund for work in hybrid projects, taking into account the changing nature and climatic components of the design environment based on the use of neural networks. To achieve this goal should solve the following tasks. The first one, substantiate the structure and architecture of the neural network to predict the natural allowable time for work during the life cycle of hybrid projects, and to carry out presentation of initial data training of an artificial neural network and estimation of accuracy of a model of forecasting of naturally allowed time of performance of work during certain days. An important property of artificial neural networks is that they are able to learn from the use of known data. The database for training artificial neural networks is the statistical data of meteorological station. In particular, to predict a fund for work performance during the life cycle of hybrid crop projects, air humidity deficit data are used, which are recorded every 3 hours in the period from 1st July to 15th August. Only those data of humidity deficit that exceed values of more than 4 and taken into account, we can see on the figure. This is due to the fact that the implementation of works in the projects of harvesting crops is possible only is such natural and climatic conditions. Failure to comply with the condition leads to a significant increase in moisture of the grain system, as well as to the loss of the crop. It's known that the transition time of the humidity deficit, however, mostly coincides with the time of appearance and and disappearance of dew. To build a system using neural networks, first of all, the choice of its architecture is performed. The architecture of the neural network is selected experimentally on the basis of the technical tasks. An artificial neural network of direct propagation was chosen for our proposed system. We can see a figure on the slide. The architecture of the proposed neural network is fully connected. In this case, the number of hidden layers should be selected experimentally, taking into account the condition that the greater the number, the more accurate will be the prediction of naturally allowed fund for work performance in a single day. However, as this increases the duration of training of the artificial neural network, the predicted quantitative value of the naturally allowed fund for work performance for the next day is compared with the real one. It's recorded in the database, after which the proposed system undergoes the next iteration of training with the shift by days. Given the fact that in hybrid projects, there is a change in natural and climatic component of the design environment, which are non-stationary, the statistical characteristics of the input signals, duration of naturally allowed fund for work performance changed over time. Therefore, for such a system, teaching methods where the teacher cannot be used as an artificial neural networks will not detect a change in the changing design environment. All the above gives grounds to claim that a given system should provide for the adaptation of network parameters to the variable duration of naturally allowed fund for work performance. In reality, the learning process of the artificial neural network in the presented adaptive system is not completed until the data for processing. The results of determine the normalized values of naturally allowed fund for work performance during a single day are given in this table. Given that the proposed system has quantitative normalized values of naturally allowed fund for work performance during a single day in the range from 0 to 1, we have chosen a model function to activate neural networks. The proposed structure of a neuron is such that will provide a single static input, which will be 1, and reflect the threshold value for neuron. The proposed neural network architecture involves the use of a multi-layer perceptron, which makes it possible to solve the problem of productive naturally allowed fund for work performance in a hybrid project. At the same time, training with a teacher is envisaged as we have available statistics from previous periods of the change in the humidity deficit, which determines the start time and duration of naturally allowed fund for work performance. Based on the comparative analysis of machine learning methods with the teacher, we choose the method of inverse error propagation. It's based on an algorithm that minimizes the forecast error by propagation error signals from the network outputs, estimate duration of natural allowable time for work to its inputs, values of the duration of natural allowable time for work in previous days, in the direction that is inverse of direct signal propagation. To predict fund for work performance based on experiments, the rational structure of the neural network was determined. 5 inputs, which will be the value of the duration of natural time allowed to perform work in 5 previous days, and 2 hidden layers with 5 neurons. To train a neural network, statistical data of the summer months of 2020 on the natural allowable time of work during certain days. which is typical for the conditions of the Volodymyr-Volynski district, Volyn region were used. On the basis of the received data and histogram of change of fund for work performance duration, which underlies training of neural network is constructed. On certain days, where the duration of the natural permanent fund for work performance was, participation was observed. Studies conducted based of neural network training show that when the number of epoching raises to more than 25,000 to predict error does not exceed 4.8%. On the basis of the performed research of the adjusted artificial neural network, the tendencies of change of the naturally allowed fund for work performance during certain days of a life cycle of hybrid projects, a real and forecasted value for conditions of the Volodymyr-Volynski area in Volhyni area are establishing. And conclusion, substantiate structure of neural network for productive natural allowed fund for work performance during the life cycle of hybrid projects provides 5 inputs that display the value of the duration of neural allowed time to perform work in the previous 5 days and 2 hidden layers with 5 neurons. The neural network architecture involves the use of a multiplayer perceptron, teacher training, and the method of back propagation. It's based on an algorithm that minimizes the prediction error by propagation error signals from the network outputs, predicted duration of natural allowed fund for work performance, to its inputs values of the duration of naturally allowed fund for work performance in previous days in the direction opposite to the direct propagation of signals. And the second one, based on the initial data, the training in the official neural network was performed, which ensures the creation of an official neural network that is able to predict the duration of naturally allowed time to perform work in a software environment written in Python. Studies based on neural network training show that when the number of epoch increases to more than 25,000, the error does not exceed 4.8%. To study the neural network, we use the statistical data of the summer months of 2020 of the naturally allowed fund for work performance during certain days, which are typical for the condition of the Volodymyr-Volynski district on the Volyn region. The obtained results indicate that the use of the proposed architecture of the artificial neural network gives a fairly accurate forecast, and this is the basis for making quality management decision on planning the content and timing of work in hybrid project. Thanks a lot for your attention.
Thank you. Thank you. Then, any questions to speaker? We hear you have some problem with neighbors. It's camp, and in camp, people preparing some happening. Therefore, maybe if you are not very stress us, let second report, Dr. Bublik, we will take into account. This will publish it and so on.
Okay, thank you.
Somebody.
Yes, may I start?
Sorry, I must start the presentation by my colleagues Vasil Andrunik and Metro Shostak. May I start?
Okay. Please.
So, hello, dear participants. My name is Solomia Albota, and the paper is entitled Recommendation System development based on intelligent search, NLP, and machine learning methods. Today, an incredibly large amount of information is stored on the internet. In addition, every day its number is only growing. This applies to online resources that contain entertainment content such as Netflix, Megago, and light stores such as Amazon, Rosetka, and others. All these systems have one thing in common. In order for users to be satisfied with the work of these resources, they must be able to quickly, easily, and efficiently research the information they need. The chosen topic is extremely relevant today because today the demand for goods offered by business, especially online, is growing at an unprecedented rate. Any intelligent search system consists of a repository where all the necessary data is stored and a program that uses certain algorithms, analyzes the input feed, accesses the repository, and returns the relevant result. The difficulty is to properly store the data and properly configure the search engine processing algorithms. Due to the use of inverse indexes, obtaining information in a huge number of documents is relatively easy and efficiently compared to traditional databases. Every user tends to make mistakes when searching. Therefore, there is a problem. So Lviv-Shatsk's distance helps us here. Considering the table, we can conclude the implementation of our system will be useful algorithm for collaborative filtering because the advantages of this method are ideal for the search engine and the disadvantages are not significant not to choose this method. Comparing all the results, we can conclude that the Lviv-Shatsk's algorithm is ideal for our system because the accuracy of search results will be the highest. This is due to the fact that Lviv-Shatsk's algorithm compares words, not phrases, taking into account the length of the change of words or the number of deletions, insertions, replacement of letters in the word. The main purpose of this system is to enable the user to conveniently and quickly find the desired product. A distinctive feature of IDF0 is the emphasis on the subordination of objects. IDF0 considers the logical relationship between works, not their temporal sequence workflow. The functional model is a set of blocks, each of which is a black box with inputs and outputs, controls the mechanisms that are detailed to the required level. Because Elasticsearch is built on top of Lucene, it outperforms full-text search. Elasticsearch is also near a real-time search platform, which means that the delay from the time the document is indexed to when it becomes searchable is very short, usually 1 second. As a result, Elasticsearch is well suited for temporary applications such as security analytics and infrastructure monitoring. MySQL is chosen for high availability, Java is chosen for free price, productivity, efficiency, portability, and as well language support. The main algorithm for the recommendations was the slow one algorithm. Applying shared filtering usually involves very large data sets. Co-filtration techniques have been applied to many different types of data, including sounding and monitoring data such as mineral exploration, large-scale environmental sounding, or multiple sensors. Financial data such as financial services institutions, which integrate many financial sources, or in e-commerce and web applications where the focus is on user data and so on. Two databases are used, MySQL and Elasticsearch. To simplify the management of database schemas, the Liquibase framework is used, which allows to easily change the structure of the database. Maven technology is used to manage the dependency between Java libraries. The main functions of the program are intelligent search for documents uploaded to the repository, as well as the possibility of recommendations for users. A number of search entries with and without the NLP algorithm were also conducted. And an intelligent search system has been developed with the ability to autocomplete search words using filters for search speed, sorting results, and also using NLP algorithms. In essence, an efficient, profitable, and stable search engine has been built for almost any type of business which contains a lot of information or goods and is on demand among users. Thank you for your attention. And may I start the second one?
Sorry.
Sorry. May I start my presentation? Okay, Sonia, please wait for me. Please don't share your presentation. Yeah, I will start. Thank you very much.
Short one.
Yes. I'm, ladies and gentlemen, I'm present the topic of intelligent system for checking the authenticate of good based on blockchain technology, done by Oleg Prokipchuk, Любомир Шарун, Miroslava Bublik, Valentina Panasiuk, Viktor Yakimtsov, Roman Kovalchuk. Now, in this past, the basic of such relation was natural production. Over time, this type of production began to display more efficiently commodity production. Such production has been consumer value and unuseful, which is enter an agreement and sell its product. Due to the impossibility competitive is simplified for the sake of the easy profit. Some producer earn by the simplifying counterfeit or counterfeit goods. The figure shows the world statistical on industrials that suffer loss from the counterfeit goods according to the Organization of Economic Cooperation and Development. The World Health Organization claims that 10% of all medicine in poor countries are counterfeit. Many modern countries take an issue of a counterfeit seriously and punish that the distributor of such products. Now, the result of the analysis of approach we have presented in this table. The main process in this chart is check the product of authenticity. The contest diagram with EDF0 is given in this figure. The decomposition of the main process is presented in this figure. The decomposition of the update blockchain status process shown in this figure. The decomposition of the check and the condition of the goods process shown in this figure. The most common and large-scale part of this work is the development of blockchain functionality. Blockchain is a distributed database which, as the name implied, is a chain of the interconnected block. This technology was first introduced in 1991 by Scott Stornett and Stuart Hubbard. The example of creation using the RSA algorithm shown in this figure. The information system of authentication group based on blockchain technology consists of two programs, product chain and product chain server. For the first step, using the program is for the conduction menu producer. After the transition, you can see the empty table of products types and position type. Product type creation windows, this in the figure 2 scan of product types. In figure, we can see 4 automatically generated transactions. 3 of them correspond to the created units of goods and have a balance of 1, and the next transaction with balance of 1,000, corresponding to the transfer funding from the base wallet to the specific type of goods. In this screen view, all the blocks and the value are written on the blockchain. By the default, this list is organized into a tree structure sorted by blocks in descending order, and all its value is collapsed. Conclusion. As a result of this work, information system for verifying the authenticity of goods based on blockchain technology was developed. All the necessary models have been developed for fully demonstrating the system operation, including blockchain models, the manufacturer to user interface, and the web server. Also implemented P2P server, which allow you interact with developed software. Thank you for your attention.
Thank you very much, Dr. Bublik. Yes, for now, who else insists to his report? because maybe somebody has questions to Dr. Bubu. What is the problem with?
Your sound is very noisy. Your sound is very noisy.
Somebody.
It's difficult to hear you. Yeah. We understand your hard work. Yeah.
Dr. Lesky, maybe close your microphone. Okay. If nobody else insists on your reports,
maybe I, Rostislav Jurinets.
You really insist?
Rostislav Jurinets.
I understand, Dr. Jurinets. Want to make it out. Okay, it will be last one, please. We are listening. Yeah. Please share your screen and Dr. Jurinets is the last report for today.
You are invited to paper Innovation and Investment Factors in the State Strategic Management of Social and Economic Development of the Country. Modeling and Forecasting. The aim of the article is the modeling of impact of innovative and investment factors on the social and economic development of Ukraine, and forecasting Ukraine's gross domestic product growth in the short term to improve the state strategic management. The model-based approach moves away from classical regression analysis, and instead uses combination of production functions and regression analysis. The forecast was made for a short-term period by means of Box-Jenkins method. Using the production function method, there was carried out the modeling of gross domestic product, Y, volume with the consideration of the amount of introduced new technologies, technological processes, total costs of the enterprises, introducing innovations and volume of financing of the research, and scientific and technological works. To build the econometric model, there was carried out the statistic information analysis of Ukraine within the period from 2005 to 2019. In the result of the carried out analysis, there was received the following econometric dependence. The forecast of the main innovation factors of Ukraine was made for a short-term period by means of Box-Jenkins method, ARIMA. In ARIMA model, the level of the time series is defined as a calculated amount of its previous values, and residual values, current and previous. The applied modeling method let provide adequate representation of the object, significance of the estimated model's parameters, and reliable results. All the built models are adequate, significant, and are characterized by high level of statistic performance. Using the statistical data, there was constructed a correlation matrix of the above-mentioned factors, the financing volume of the research, scientific and technological works, total costs of the enterprises, introducing innovations, the amount of completed research, scientific and technological works, the number of applied inventions. Analyzing the correlation matrix, there was detected the influence of each factor on volume of financing sources of the research, scientific and technological works. On the basis of the achieved parameters, the factor model will appear. Based on the econometric model, there was made a forecast of influence of scientific and technological works volume and amount of completed research, scientific and technological works on the volume of financing sources of the research, scientific and technological works. The achieved results have showed that financing of the research, scientific and technological works will gradually decrease in future. At present, the government financing of scientific and technological activity in Ukraine is bound with the development of innovative technologic modes, and promotes economic model construction that does not need any innovations, and does not form any impulses for the investments to human capital assets development. Based on the econometric model, there will be made a forecast of influence of the number of the inventions used, the research and development works volume on the number of completed research, and scientific and technological works. It is worth mentioning that the indices of effectiveness of the use of scientific potential in Ukraine, which are manifested in the amount of completed research. Scientific and technological works are still low and actually are not going to be increased in the long view. Not very positive dynamics of the total amount of completed research, scientific and technological works is caused by decrease of quantitative indices related to the results of scientific potential use, gradual decrease of relative share, and the innovative work quality, enforcement of compilation of the scientific and research works, absence of demand for them in the national production, non-compliance with market demands and world trends. On the basis of econometric model, there was made a forecast of influence of the number of the granted patents in Ukraine and number of organizations conducting the research works, and explorations on the amount of realized inventions. In Ukraine, the amount of realized inventions decreases every year. As may be seen from the figure, the number of the realized inventions will decrease year after year. According to the realized inventions per 10,000 people, Ukraine by 12 times remains short of the average level of EU, however, at the same time by 1.7 times anticipates it in the number of scientists per 10,000 working people. To forecast gross domestic product, using the offered econometric model, it is necessary to make a forecast for all the model factors that characterize the scientific and innovative activity of the country. The results of econometric model construction are shown. The derived estimates allow using the model for gross domestic product forecast. As is seen from the above mention, gross domestic product forecast value will gradually decrease over the long term. It should be mentioned that the developed countries pay much attention to the development of technological and innovative activity. Unfortunately, in Ukraine the factors that influence gross domestic product growth are neglected. The primary task of the model for gross domestic product forecast is to provide with the basic material for further researches, to serve as a tool for the effective state's strategic management and formation of the strategies and programs of social and economic development at different levels of national economy.
Thank you.
Dmitro, you are muted.
Не чути вас.
I have a question.
Is it a machine voice?
Any questions to Dr. Uranes?
I have a question.
Yes, I have a question about presentation. Did you use a machine voice in your presentation? It's your voice.
No.
No, not yours. Okay. Not everybody understands that it's a robot's voice.
Yes, robot voice.
What kind of program do you use for this?
Dr. Emmerich, please.
What program makes this robot voice?
What program?
What program? 1 minute, I give.
It's very.
Next conference should be robotic.
I in chat give.
In the chat. Okay.
Maybe you write in chat.
You write in chat. Yes, write in the chat of
In the
Zoom.
chat.
We are interested. It's a good robot voice.
Yeah, quite a good sound. Then,
It's yes.
by the way,
About your talk, I have a question.
okay, please.
About content of talk. In scientific innovation, do you count only patents or also publications of scientists?
It's a demo. It's demo.
No. About about content of your report. What data you used?
Also publications of scientists, or are you only looking at patent?
It's free. It's free.
Пане Ростиславе, маємо на увазі матеріал, з яким працюєте. Чи це є патенти, чи це якісь інші публікації та матеріали?
Ні, ну це моя публікація. Питалася про голос. Чи це мій, чи можна...
Ще забули про голос, говоримо про зміст вашої доповіді.
Матеріали, над якими,
Ага.
тобто ресурсна база, яку обробляєте, опрацьовуєте.
Я не зрозумів запитання, яке ще раз.
З яким текстом працюєте? Тобто ви для аналізу взяли тексти патентів, які обробляєте, так, на яких будуєте?
Ні, statistical data, статистичні дані.
На чому ви їх будували?
Я понимаю.
Statistical office data.
Okay.
It's official statistical data.
Okay, я понимаю. I understand.
Okay. Thank you. No any questions? No. Then I should, on behalf of the program committee, organizing committee, yeah. Thank you, everybody, for participating, especially reviewers, sub-reviewers, for their efforts. And for now, this workshop is closed. Thank you very much.
Thank you, Dmitro, for organization.
Cool.
Thank you very much. Thank you.
Goodbye.
Have a good day.
Have a good day.
Thank you.
Have a good day.
Thank you for organization. Good, great work. Yes, thank you. Thank you very much.
We hope next time will be even better.
Next time will be in person. And do you have, in the next year, it would be nice to have a conference again together in Shatsk or hybrid format.
Yeah, and hybrid. And the people participate personally.
Given all the difficulty, you did very well.
So we'll be here.
Mosquito.
Thank you and goodbye for today.
Goodbye.
Thank you.
Bye.
Thank you, Victoria and Dr. Emmerich too. And bye.
Bye.
And goodbye.
Good luck.
See you luck.
Goodbye.
See you luck. See you soon.
Thank you. Goodbye.